Okay, we are continuing with finding the indefinite integral. And so what we have here is the indefinite integral of 9t squared plus t over 8, and then it says dt. This dt right here tells me that the variable that I'm going to be taking the antiderivative or integral of is the variable t. So we're going to follow this reverse power rule to find the antiderivative that I've given here where it says recall. Okay, so what we're going to do is we're going to look at each of these piece by piece, and we're going to take the antiderivative by applying the reverse power rule. So let's see here. I have 9t squared. I'm going to add 1 to the exponent, 2 plus 1, and I'm going to get 3, so I divide by 3. Now I'm going to add my t to the power 1 plus 1, and then divide by 8, of course, because that's what it was being divided by, and 1 plus 1 is 2, so I'm going to divide by 2, which is the same as multiplying by half. And then, of course, I have to add in my arbitrary constant of integration. So I'm almost done. I have 9t to the third power divided by 3 plus t to the second power, and then you can multiply the denominators of the fraction over here, 8 times 2, and that gives you 16. And then, of course, you tack on your arbitrary constant of integration, and we're almost done. We just need to do a little bit of reducing. So now we have 9 divided by 3, which is 3t to the third power, plus, and then you end up with t squared over 16 plus your arbitrary constant of integration, c. So a really nice and simple example here of applying the antiderivative to find an indefinite integral. So let's take a look at another example, and this next example right here requires you to think a little bit more algebraically, but it's okay. It's a really nice example, and it's good to get exposure to varying levels of difficulty of these kinds of problems. So let's take a look at this one. I have the integral, the indefinite integral of 1 over x to the fourth minus x to the fourth minus 1/2, and then it says dx. This tells me here that the variable that I'm taking the antiderivative of is x. So what I'm going to do is I'm going to look at it term by term in following the reverse power rule. So let's go ahead and take a look. First thing I need to do, though, is rethink the way that it looks. So before I do this, I need to write 1 over x to the fourth as x to a negative 4. So you've got to recall the negative exponent rule from your Algebra 1 course. All right, algebra plays a heavy part in calculus, so keep that in mind here. All right, so now I'm ready to take the reverse power rule. So what I'm going to do is I'm going to say, okay, x to the negative 4 plus 1. Now here's where a lot of students mess up. They'll say negative 4 plus 1 is 5. No, that's not correct. Negative 4 plus 1 is negative 3. So I'm going to divide by negative 3. I'm going to then subtract, and then I have x to the fourth plus 1. Now there's your 4 plus 1. You divide by 5. And then negative 1/2, you just tack on an x, and then you can't forget your arbitrary constant, c. So we're almost done. We've just got to clean it up just a little bit. Okay? So we end up with something that looks like this. Suppose x to the negative 3 over a negative 3 minus x to the fifth over 5 minus 1/2 x plus c. Now there's just one more step to kind of making this look pretty, and that is to bring this x to the minus 3 down to the denominator because it is a negative exponent. So we're going to clean it up just one more step. Okay? I'm going to end up with a negative 1 on the top because it's negative in general because of the 3 in the denominator. And then in the denominator, I'm going to have 3 and then x to the third power and then minus x to the fifth over 5 minus 1/2 x plus c. And so it looks something like that. Okay? Really nice, really clean, and just a really neat example. All right, we'll take a look at one more example. And on the next example, again, you've got to have that algebra thinking hat on because this one makes use of square root and cube root functions. So think about that. What does that mean in terms of a power? Because remember, we're doing the reverse power rule for antiderivatives here. So we have to rethink the way that it looks. So let's go ahead and take a look at this. A square root of t is always the variable to the 1/2 power. So it's going to be t to the 1/2 power. And then the cube root of t will be t to the 1/3 power in this case. And so that right there is what we take the antiderivative or indefinite integral of with respect to the variable t. So that's the variable that's in play here. So what we're going to do is we're going to look at this again term by term, t to the 1/2 plus, all right, now I've got to add 1. So you can add 1, but you need a common denominator. So it's just best to express the 1 in terms of a fraction that has the same denominator. So in this case, 2 over 2. All right, so 2 over 2. I'm going to have 1/2 plus 2 over 2. If it was 1/3, I would add 3 over 3 and so forth and so on. And so 1/2 plus 2 over 2 is 3 over 2. So I divide by 3 over 2. And then I'm going to subtract, and I have t to the 1/3. And I'm going to add, in this case, 3 out of 3 because that's a representation of 1. And so 1/3 plus 3/3 is 4/3. So I'm going to divide by 4/3. And of course, I cannot forget about my constant of integration, c. So I'm almost done here. I've just got to do a little bit of work in terms of clearing up the way that these fractions look. So when I have t to the 1/2 plus 2/2, that's t to the 3/2. But when I divide by 3 over 2, that's the same as multiplying by 2/3. Okay? And then the same thing happens over here. If you're dividing by 4/3, it's the same as multiplying by 3/4. And then you get t, in this case, to the 4 over 3 power. Okay, so the 4/3, we divide by 4/3 becomes 3/4. Okay, so we are set. We just tack on our constant of integration and we're good to go. So again, really nice examples and varying levels of difficulty here on how to take an antiderivative by applying the reverse power rule. So really neat, really simple. If you knew what was going on with derivatives, then the antiderivatives aren't going to give you too much trouble. It's when we get into definite integrals, which is going to tell you there's limits of integration that you may have trouble with, but it's just some simple arithmetic. Otherwise, it's really nice. So as always, I hope this video was helpful. And remember, like and subscribe.